So I think this quotation here is sort of covering a point that I've made already, that the criteria we use to assess how good a model is, there's no standard criteria. It depends on where you're coming from and the application that you're interested in. And often, for example, significance tests seem to be, they have traditionally been sort of taken as the sort of standard, but in fact it really depends on where you are and what context you are, what degree of chance finding you will tolerate and can work with. So that's just one of my collected quotes. So now I'm going to look through some examples. We may not get through all of them, well, let's see how we go. So I'm going to look at one analysis of project proposals that came to a funding mechanism in the UK, and how the attributes of those project proposals related to their subsequent success. I'm then also going to look at NGO working relationships with each other in Indonesia and predictive models of what constituted a successful working relationship. Also look at predictors of household poverty status in Vietnam. A brief reference to positive deviance, looking at that at the Crook data set that we've just been looking at. And also, if we have time, looking at a reanalysis of synthesis of evaluations done by Oxfam. So the Civil Society Challenge Fund was a mechanism for funding NGO projects in Britain, and it came to an end in 2015, and I was asked to help try and get more value out of a data set they had, which included data on the project proposals, on the attributes of all those proposals, and I also had some data on the subsequent performance of those projects at different points in time. But basically they had a hell of a lot of data and not a huge number of cases. Question that we came to earlier. So we try, one way of dealing with that is to use this matrix that I've got here, where we tried to categorize the outcome data that they had across the top and categorize the independent variable data, notionally, into groups down the left. And so that gave us a matrix of possible relationships to look at. And consulting with a core group of staff, I got them each to identify which set of relationships they wanted to prioritize to do this predictive modeling with. And you can see that what we did was we only analyzed a minority number of the possible analyses that could be made. But the advantage of doing this was that we made it very clear what we had not analyzed. So if people had questioned our results, we would be very clear in saying we haven't done every possible analysis. Our conclusions here are not, the whole picture, but at least we're showing very clearly what we have not done and what we have done. So the findings from this particular analysis, when we, I should go back a step. If you look at the project appraisal row and then the project performance column, that's one coloured in cell, and that's one analysis that I'll talk about now. So when we did that analysis, the findings weren't very positive. And in fact, it wasn't project appraisal scores, it was project appraisal attributes as predictors of subsequent project performance ratings. And in this case, we dichotomized the project performance ratings in three ways. We separated out the top performers, the middle performers, and bottom performers. So we had three separate columns in that data set. And the best predictive models that we could find were terrible as predictors of the top performers. Lift is one of those performance measures that I didn't show you, but below accuracy. And the middle performers, it was better than average, better than chance in identifying the middle performing projects. But what really worried me was its capacity to identify the poor performing projects was abysmal. That's not something that you want to find in a project screening process where you're making decisions about funding, that you actually cannot identify the projects that are going to bomb. Now, you might reasonably say, development projects are full of lots of unpredictables and uncontrollables, and so it's a pretty hard task to to do in the first place to identify things which are going to work and those which aren't work. But I think this level of non-achievement is seriously worrying. But why did it happen? Well, when we look back at the data set, it wasn't necessarily a problem with the appraisal process. Actually, it was a data problem. And when we looked at the ratings of project performance, in fact, there wasn't enough. There wasn't enough range in the performance values to enable any algorithm to find a model that would predict the poor performers. And so that's one thing to be mindful of when you are doing the pre-processing, planning for a predictive modeling exercise, is to make sure that whatever fields or variables you've got have got a sufficient range of values, because if they haven't, they will seriously limit the capacity of your model to either predict that event or use it as a predictor. So the next example is from the Basic Necessities Survey of households in Vietnam in 2006. Here we had a bigger number of households, almost 600, and we asked them questions about 33 different items in their household, whether they possessed them and whether they thought they were basic necessities. And then a poverty score was calculated, which took into account what they had weighted by the percentage of people who thought it was a basic necessity. This is a sort of retrospective, opportunistic analysis. I was interested in finding out whether we could develop a simple predictive model that would mean that you wouldn't have to resurvey households again, taking up all that time to find poor households if you wanted to target a new development intervention, but you just wanted a couple of rule of thumb indicators, which if you found these things, that would tell you, yeah, these are poor households, perhaps we should include them in the program. So this is probably going to be a bit of a headache to look at, but this is a decision tree model, and it's like a tree that's fallen over on its side, and each branch of this tree is a particular model. So the way I'll read it is, if a household has an electric rice cooker, and they have a pesticide pump, and they eat meat once a week, it's highly likely that they will not be poor. 213 households were not poor, and 33 were poor. On the other hand, if the household doesn't have an electric rice cooker, it doesn't have a water pump, and it doesn't have a fridge, it's highly likely that they will be poor. 185 of those households were poor, but 29 were not poor. But there are some other, there's one other model there which is a bit more mixed, which says, okay, if they don't have a rice cooker, but they do have a water pump and a watch, well, it's likely that they will not be poor. So each of those is a potential, those sets of attributes are potential identifiers of poor and not poor households. But as you can see, none of them are perfect, with the exception of, no, none of them are perfect predictor models. So how worried should we be about that? Well, it depends on if in targeting poor households, whether we worry whether some rich households or not poor households also get some of the benefits or not. Quite often that's an affordable cost in trying to develop a program that does reach poor households. Ignore that comment on the left, I'm not going to explore that. So the next example is from Indonesia, looking at 13 NGOs who are working with each other and with other government and NGO and private sector organisations in South Sumatra trying to deal with deforestation. And we were inquiring about who they were working with and how successful those working relationships were. It was dominantly a social network analysis inquiry, but one element of it asked them to identify some aspects of their relationship, and that's what I'm focusing on here. So we asked them to list 10 partners they were working with, they worked with the most in terms of time in the last year, to sort those into 2 equal-sized groups, one of which they described as more successful working relationships, the other one is less successful. So that's the outcome variable in that data set that we looked at earlier. And then we presented them with a menu of attributes of those relationships and asked them to choose from the menu which attributes best describe the more successful relationships And then bearing in mind asymmetry, we asked them to look from the menu and choose which attributes best describe the less successful relationships. So that provided those other columns in that data set. This survey is like an equivalent to a card sorting or pile sorting exercise used by anthropologists and ethnographers, and these days by website designers as well. So this is the menu of items that we asked people about. We start off just with a word and then with a phrase expressing that availability. I've been able to contact them when we need to. Does that apply to the group of relationships you describe as most successful or not? Motivation. They've been willing and interested to engage with me. So this is a menu that they chose from. So this is a lot of binary options, yes or no, and they can pick as many as they want. So that menu is another example of what I describe as a loose theory of relationship attributes. And I like loose theories because it doesn't get us caught into one normative perspective of what a good NGO working relationship looks like. It enables the participants to exercise some choice in their definition. But at the same time, because it's from a limited menu, it means there are comparable answers. We can compare the respondents in terms of their answers. And so when I looked at the response of this survey, we were looking for what combinations of relationship attributes were good predictors of whether a working relationship was successful or not. I was also interested to see whether these predictors whether it was a symmetric or asymmetric situation, whether the predictors of unsuccessful working relationships were quite different. I was also interested to find out whether there was a single coherent view amongst the NGOs about what constituted a good working relationship, or whether in fact there are different views. So we would need multiple models to explain their judgments. And I was also interested in testing the prior theories through a feedback workshop, but I was not there at the time of that workshop, so I wasn't able to be involved in that process. I'm just going to click through that. So this is, in summary, some of the results. Basically, availability, the person being there and accessible when you wanted to talk to them, was a necessary but insufficient attribute. It was necessary for any relationship to be judged as successful, but it wasn't sufficient. Other attributes were necessary in order for that judgment to be made. And in fact, the best single model combining attributes was their presence of motivation, efficiency, and availability. These are attributes describing the other partner to the relationship, their willingness to talk, their use of time, and their availability. And you see I've got the accuracy measure there that I talked about earlier. It wasn't an asymmetric, we didn't need, it wasn't a situation where an asymmetric model was appropriate or that fitted the circumstances. It was simply the absence of motivation was also a good predictor of less successful relationships. What was interesting was the number of views. There were 3 different models necessary to account for all the judgments of successful relationships. So there wasn't a single unitary view amongst the 13 NGOs, but there wasn't an incredible diversity either. Oh, beg your pardon. 3 models of successful relationships and 5 of less successful. I eat my words. And how do I go from here? Sorry. Don't know what's happened here. Okay, this is just another decision tree model showing basically what I explained before. So at the top, we've got the presence of motivation, the presence of efficiency, and the presence of availability, and synergy being a model predicting successful working relationships with one group of NGOs. And I'm looking for... basically, there are 1, 2, 3, 4, 5, 7, 8 different models altogether. That's probably a bit more detail than we need at the moment. Okay, so going back to the Crook data set, one way of finding positive deviance is that you try and develop a predictive model of the absence of the outcome. In this case, the best predictive model of the absence of an outcome was the absence of quotas. And you will see, if you can, there are 13 true positive cases, 4 false negative cases, so it's not always a good predictor. There are some cases where women's representation is low but is not explained by the absence of quotas. But what's interesting is there is one false positive. So a positive deviance is a rare case of something, an outcome happening when all the circumstances suggest it won't happen. And this positive deviance case here is Lesotho, which is surrounded by South Africa. It's got very different employment opportunities to many other African countries. And I don't know enough about Lesotho to explain any further why it is a positive deviance case, but it quite clearly stands in contrast to the 13 others which don't have quotas. And that's a sort of case where it would be really interesting to explore and understand in more detail how it is they've managed to have such high levels of women's representation. So the last example I'll come to is this meta-review by Oxfam of their policy influencing programs. And in this case here, they had already used QCA to do some analysis of the 24 of their programs. And I took the data set from that analysis and reanalyzed it. I have discussed this with Oxfam. I had ran a workshop for them last week and we had a discussion about that then. So they had 2 different outcomes which they were interested in. One was expanding civic space, which is defined here, and the other one was changing policies. And I'm going to be talking just very briefly about the analysis of expanding civic space, I think. And they had, through looking at the evaluations, they had identified 5 possible explanatory conditions. In QCA terms, a condition is the same as an attribute in the data set that I've been talking about here. And in data mining, often they use the word feature also as a synonym for attribute or condition. So they had identified 5 different possible explanatory conditions for where expanded civic space might have been achieved. So that 5 gives us, what, 2 to the power of 5 is 32 different possible combinations that might explain when it's achieved or when it's not. And the result of the QCA analysis came up with 4 models, which are explained here. And each of these models involves 2 attributes. The first one was an insider strategy and an opportunity approach. Forgive the jargon, just work with the jargon because it's really just looking for how they've done the analysis rather than the content. So they had 4 different models that they found here, and they've told us how many cases are covered by each of these models. So when I reanalyzed the data set, and I'll show you the data set shortly, I found that the first 3 models, I found exactly this. I found they fitted equally well when I did the analysis, and each was sufficient for the outcome to take place. The 4th was not, and it covered more cases, but with more false positives. So I can't explain that at the moment. I'm really puzzled about why. Because often when you do this sort of analysis with QCA data, often the findings are broadly comparable, which is heartening. But the main thing to note when I did this was that there was a lot of overlap in the coverage of those 4 models that Oxfam had analysis has identified. And that poses a problem because it suggests they've got more work to do. The evaluation team have got more work to do. You can't just leave 4 models which are covering very similar cases, and just say, well, we've got 4 different models, but actually we don't know which one applies to which of these cases. So I felt the analysis was incomplete. And when I constructed a decision tree model to find models that fitted all the outcomes, this is what we saw. Oh, sorry, this is just their 4 models and the amount of overlap between them. So you can see quite a lot of overlap between these 4 models. So there's a lot of work yet to be done to resolve this. This is the decision tree model, which came up with a rather surprisingly sort of succinct model. It basically said the best performing model here is there an opportunity present in a project situation for expanding civil spaces? It was a one variable explanation, but it explained covered 10 out of the 15 cases. And then the second model was, where there's not opportunity, but there are multiple levels of intervention and there is an outsider agent present, then that covered another 4. So it left only one outcome not covered by the model. So in this case, the analysis was quite different. And in a decision tree, there are no overlaps between these models. The cases they all cover are unique. So we got past that problem of overlapping models. And we've also produced an analysis which is more succinct in terms of economy of attributes need to explain the outcome. And so one of the questions I was interested in is, why did my results turn out different to the original QCA analysis? And again, I think it's a matter of looking at the data, but it wasn't a problem with the data this time, but with the algorithms used. This is the data set. The top half are real cases that they had data on, and the bottom half are configurations which in theory could exist, but they had no cases as examples of those. They had 26 and there were 32? No, I can't remember how, but they had a lot more possibilities there than they had cases for. Now, QCA uses something called the Quine-McCluskey algorithm to try and minimize the number of configurations down to that set of 4. But this algorithm has a particular requirement that it can only minimize if it finds configurations which are only one attribute difference. And in a small data set, in a data set with insufficient variety, it can't work very well. And so it ends up generating more models than you need to, and you can find a simpler approach using other algorithms. So the message out of this reanalysis was, don't just rely on one algorithm when you're trying to develop predictive models, because all algorithms have weaknesses, and that includes the one used by QCA. So, key points from this third segment. The significance of data preparation and looking at the distributions of the data in the Civil Society Challenge Fund dataset, where the outcome measure was just insufficiently variable. Secondly, the usefulness of predictions by themselves, just finding a predictive model of when a household is poor or not. That can be quite useful in many development programs. Thirdly, the usefulness of loose theories, that menu of possible descriptors of a successful working relationship is flexible but manageable as a means of analysis. And fourthly, the importance of reanalyzing data, of finding different interpretations and different results in the same data set, which I think is a useful lesson for all of us in terms of being too confident in our own analyses. Someone will probably come along and reanalyze what I've done. And on that point, I think I'm landing here, which this comes from the medical sphere, but it is related to the whole debate about the replicability crisis in social sciences particularly, but sciences more generally. A disconcerting number of findings, when people reanalyze them, find that they don't stand up to their original conclusions. Right. There's some links to the website, to my website and Twitter feed, but I think we'll just hand over some questions now. We've got at least 15 minutes here for discussion. Anybody got